In this video, you'll see how to create a secure DevOps pipeline for AWS Service Catalog. With this solution, you can leverage reference architecture from GitHub to easily set up a continuous integration and continuous delivery, or CI/CD pipeline, that employs DevOps and Infrastructure as Code, or IAC, practices. We'll begin from the GitHub repository that contains the AWS Service Catalog reference architecture for the CI/CD pipeline. This diagram gives a quick overview of the reference architecture. The Service Catalog reference architecture portfolio contains instructions and links for single-account and multi-account setups. For this example, we'll deploy the architecture for a single-account setup. For demonstration purposes, we have already launched the stacks and set them up in our AWS account. Let's take a look. The reference architecture created a portfolio with the Service Catalog products needed to deploy the pipeline. Note that we'll be deploying the pipeline alongside Amazon Elastic Compute Cloud, or Amazon EC2, but any AWS resources that can be defined and provisioned through Service Catalog products can be used with this solution. The reference architecture also provisioned two identity and access management groups for Service Catalog end users. In addition, the portfolio includes an AWS Cloud9 Integrated Development Environment, or IDE, we can use to edit code and push changes to the code commit repository. You can, of course, choose to configure your local development environment for this purpose. We'll retain the default instance settings. Next, let's go to CloudFormation and find the Git repository URL in the code pipeline stack outputs so we can associate the repository with the development environment. Let's copy the URL and then return to the Cloud9 provisioning wizard to paste it in. Let's also specify the base folder path name for our Git repository. The EC2 reference architecture requires that we specify two tag values before we can launch the product. Now that the environment has been provisioned, let's view its outputs so we can begin editing and deploying Service Catalog product templates. Here's the URL for the Cloud9 IDE. We are now in the Cloud9 environment. The Git repository we specified in the provisioning wizard is automatically cloned to our current directory, but it is empty, since we have yet to push anything to it. Let's copy the deployed templates from the reference architecture repository to the Service Catalog portfolio's repo folder associated with the pipeline. Next, let's look at the repository that has been linked to our code pipeline resource. Since we'll be working in a single account setup, we need to make some minor modifications to the build spec file so that it executes successfully. Let's uncomment the command to run CloudFormation updates and comment out two lines relevant to a multi-account setup. Next, let's add the template files to our Git repository and commit the changes. Finally, let's push the changes to the Git repository hosted on CodeCommit, which was automatically deployed alongside the code pipeline resource. This will trigger the code pipeline execution. Let's go to our pipeline to see the execution taking place. The execution has begun, indicating that the Git repository with our Service Catalog product templates is associated and configured correctly. Let's skip ahead to when all steps have been executed. As you can see, the pipeline has successfully sourced all files from our CodeCommit Git repository, validated and linted our template files, and deployed the templates to Service Catalog as products. Let's take a look at the template validation steps build execution details. The CFN-NAG linting tool looks for any potential format or syntax errors in the Service Catalog product templates before they are deployed to end users. Templates with errors won't be deployed. Next, let's look at the copy and deploy step. This step deploys the validated Service Catalog product template files to Service Catalog. Let's go to Service Catalog to see the products from an end user's perspective. So far, we haven't made any changes to the product templates. To demonstrate that the pipeline is functioning correctly, let's make a change to the Nginx demo web server. We'll restrict users from provisioning these web servers with the T3 large instance type. To do so, let's return to our development environment. Let's open the JSON file that specifies the Nginx Demo Web Server Service Catalog product definition within our Git repository. We'll make a change to the product version number. Next, let's open the JSON file corresponding to this product's end-user provisioning parameters. We'll remove the T3 large option from the list of allowed instance type values. Now let's add, commit, and push our changes to the Git repository, which will again trigger the pipeline execution. The pipeline has finished executing. Let's return to the Service Catalog end-user view and see if our changes are reflected in the product. As expected, the product version has been updated to 1.1. Let's provision an Nginx web server through Service Catalog to see the list of available instance types. The T3 large instance type is not available, indicating that our change is reflected and the pipeline is functioning correctly. You've just seen how to create a secure DevOps pipeline for AWS Service Catalog. Thanks for watching. Now it's your turn to try.